Hello everyone, I am Soumyasree here. Today we will discuss about simple stress and strain. Okay. Simple stress is your, to know simple stress we have to know about what? A prismatic body. So, what is a prismatic body? A prismatic body is a structure in which all the cross sections are same. If here ABCD is your prismatic body. So, in ABCD here it is your E dash and this is your F dash. So, cross section along E dash and F dash is same. So, this is called the prismatic body. Okay. So, what is stress? Stress is your internal, it is an internal resistance offered per unit area, against what? Against your external force. Okay. So, here this is your definition. We know two terms, that is internal resistance. What is internal resistance? Okay. If I try to break this pen, okay, I will pull it or push it, but it will not break. Why? Because it has some internal resistance. Application of force by me is less than the internal resistance of this pen. That is why this term internal resistance is used here. In any body or any subject, there has some internal resistance. Okay. So, what is the definition? Is it is an internal resistance offered per unit area against external force. Per unit area means if ABCD is your subject or any particular object. Okay. So, in this ABCD structure, ABCD is your rectangular structure. If the value of length and width will be given, so we can calculate the area of this structure. Okay. Against external force. Okay. If the force applied is your what? P. Okay. The force I have applied here is P force. So, that is the external force. The external force is comes from outside, okay, and resistance always comes from inside. If internal resistance and external force is equal, then your force will be 0. Okay. Now, stress is always denoted by what? It is denoted by sigma. So, what will be your formula? Sigma is your P upon A. P is equal to your force and area of the body or structure. So, the unit will become, for force we will take kilonewton per meter square, or it will be your Newton per meter square, or it will be your Newton per mm square. Now, this term Newton per meter square is also termed as what? 1 Pascal is Newton per meter square is your 1 Pascal. Okay. Now, we will learn some what? Some units. Okay. If increase in units will occur, it will become 1 kilopascal, 1 megapascal, 1 gigapascal or 1 terapascal. 1 kilopascal is your 10 to the power 3. It will become 10 to the power 6. Gigapascal is your 10 to the power 9. Terapascal is your 10 to the power 12. If units will decrease, it will become here this MPa, what is megapascal, is in capital letter, capital MPa, but small p is your micropascal, that will be 10 to the power minus 3. Next one, it is your 1 millipascal, your micropascal, 10 to the power minus 6. Then nanopascal, that is 10 to the power minus 9, and picopascal, 10 to the power minus 12. Okay. So, if it is given 1 into 10 to the power 3 Newton per meter square, okay, we can write it also what? 1 kilopascal. Likewise, these units are needed in numericals. Okay. Now, we will study about types of stress. First, stress is of two types. Your direct stress, another is your shear stress. Again, direct stress is divided by two types. One is normal stress, another is your bending stress. Okay. And shear stress is also divided into two categories. One is your what? Normal shear, another is your torsional shear. Okay. So, normal stress is categorized into two types. One is your tensile stress, another is your compressive stress. Now, we will discuss these types of scales, starting from okay. Here first is your normal stress and here is your direct stress. Okay. Here is your normal stress okay. What is normal stress? Normal stress is your when stress acting normal to the surface. When stress acting normal to the surface or normal to the plane. Okay. Normal to the stress means normal to the surface means if okay, if here this is your one object. Okay. If the force acting perpendicular to the object, that will become your normal stress. Okay. Now, what is your shear stress? Shear stress is your if force acting parallel to the body. Okay. What is parallel? We all have seen railway tracks. Railway tracks, two tracks are parallel to each other. Okay. When here, if here this is your object, by taking this fix A and B, if it will be fixed. Okay. So, parallel force will be act like this. So, what will happen? This end will be constant, but this structure becomes like this. This will tilt. When shear applied, the structure becomes tilt. Okay. So, the definition will be your when applied force is what? Parallel to the structure. Parallel to the structure, it will be termed as shear stress. Okay. So, normal stress is denoted by sigma, shear stress is denoted by tau. We need to remember this. Again, here we have learned about normal stress and shear stress. Now, going to direct stress. Okay. What is direct stress? Direct stress is nothing but normal stress, but it is categorized into two types. One is tensile stress, another is your compressive stress. Okay. First we will learn about tensile stress. the definition is when stress induced in a body the applied force is a pull that will result into what? Elongation of the structure. Result into elongation of the structure, or you can say object. Okay. So, what this definition is by drawing a object. Okay. We will learn by drawing this. Okay. What is pull force? Here the term pull is applied. So, what is pull force? Pull force is your when we pull or apply some pull force in any structure. Okay. So, what will happen if the force P is applied in this structure? So, the structure will elongate in which direction? In the direction of length. Okay. So, if one side elongates, what will happen? Another side contracts. Okay. So, if one side elongates, another side contracts. So, as the structure becomes more elongate, it will always be in positive. So, tensile force is your positive force. Okay. Now, what is compressive stress? Compressive stress is your when stress induced the force applied is a push force which results contraction of the object. Okay. If this is the object, we will try to push each side of this object, but as it has more internal resistance, it will not contract. But if we take one spring, okay, imagine one spring is here. So, if we push from each side of the spring, so what will happen? That spring will contract. Okay. How? Here, if this is the object, so force applied will be from this. Okay. If force is your P, this structure will become it will contract in which side? In length side. So, it will also elongate from another side like this. If length is contracts, width is elongates. Okay. So, we have studied about what? Direct stress, compressive stress, shear stress and all. So, in case of shear stress, normal stress is equal with shear stress, but what is torsional stress? Torsional shear. If force applied if applied for, okay, we have to remove, okay, if applied force is same but act opposite, but act in opposite direction, but act in opposite direction, like we have to know by diagram. Here, if the force applied is from here and from here, okay. So, what will happen? We all know one word, twist. What is twist? If applied force is from different directions, so twisting of the material will occur. This point will twist or turn, okay. So, torsional shear is also called one what? Twisting force, okay. So, now what we have learned about here, okay, normal stress, shear stress, direct stress, bending stress. Normal shear is your what? Shear stress is normal stress, and torsional shear also tensile stress and compressive stress, but here one bending stress is left. Bending stress we will teach in another video where we have learned about what? Bending movement, okay. So, all stresses we will know, okay. Next another one is your what? Strain. What is strain? Strain is your, it is the ratio of, it is the ratio of change in length to original length, okay. So, by drawing one diagram, what? Here if AB length is your what? L, okay. If we have applied one force, that is P, force P is applied here. After application of force, what will happen? This AB will become what? AB dash, A dash, B dash, okay. What happened here? Here elongation occurs, that A becomes A dash and B becomes B dash, okay. This is your change in length delta L, also B to B dash is your delta L, okay. So, the formula will become, okay, strain is denoted by small e, small e is will become del L upon L, okay. Okay. What will be the unit? Your unit will become, if here del L is in your meter or centimeter or millimeter and L is in meter, centimeter or millimeter. So, meter will be cancelled. So, we can say strain is your what? Strain is unitless. Okay. We need to remember. Today we have studied here types of stress and what? And strain. Okay. Types of strain and strain. Next we will study about bending moment, shear force, those things. Thank you so much.